It boots into DOS, and no matter what happens here, like some of you will get an error that will say severe error. Well, that's just because it's no network card in there. It's actually looking for a network driver. So even if it says severe error, just hit enter and ignore it. It's not a real error. Okay? When you get to the DOS prompt, to start the DDI, it is DDI. That's all you're typing, DDI. Can everybody see that? It's DDI. Hit enter. That's it. That's all you got to do right now. There are some command line switches that you can type under certain conditions, but don't worry about them. Deepspar will tell you if you need to. Otherwise, you're running. Now you're up and running. Okay? Now I've got a destination. I have to, every time that I power off or whatever, my drives won't be on, so I'll have to manually go through the process of always powering up my drive, adding it back to the list, which is what I want to do. I don't want it to happen automatically. Okay? So I'm back in the Deepspar. Now I'm going to power up my source drive. F11 is the power on. If there's nothing else you remember today, remember F11 is your power on and F12 is power off. So, oh, you know what? I pulled all the cables off to show. Alright, so when I'm powering off and powering on, what will happen is, in the top left-hand corner, you see that 0, 0? In the top left-hand corner, that's tracking the state. Right now, there is no state. I'm going to switch to physical. It's going to be a physical connection. So when I power it on, I'm looking for it to go. It'll go from busy to a state of 3. 3 is what you want. That's physical connection. And then drive seek complete, drive ready. That means it's read, the head has actually seeked the system area. It's read some tables and then returns. Now I have to rescan my bus. So far I've only hit F11. Watch to see what happened. Then hit R. Okay? So now that I've rescanned my bus, now you'll see. I have a 320 gig drive here. And I have a 100 gig drive here. Now let's say I make a copy of this. Let's say I'm successful and I image this hard drive. If I take that hard drive, if I take my destination after I made a copy of it, a clone of it, and I move it over. If I use, let's say I use a piece of software. You've all used data recovery software before, right? You've all used like a Pandora or Bar Studio or something. You hit scan and it pulls your whole hard drive and builds you a tree. Yes? Right? Or Encase or whatever. It doesn't matter. How much of this drive am I going to look at when I tell Encase or Pandora and my whole thing? When I give it this destination drive, how many sectors is it going to look at?
All of them.
All of them. So whatever I told it to look at, I'm going to see all of them, right? So right now, it's 320 gigs, so it's 625,000 sectors, right? That's what I'm going to be looking at. What is my source drive? How big? So what? So if you take this number and you divide by 2, it'll balance out about 93 gigs or so. But it's a 100 gig drive. But it's that would be 160 something. There's always a little bit off. I can do the math, but basically we're at 200 divided by 2. So it's a 100 gig drive. Okay, everybody good?
We never had 100 gig drives. We only had 80, 40, 80, 120.
No, we had 100 gigs. 100 gigs are older. In the first rev of drives, the first generation of drives, they were hundreds. And then we went from hundreds to 200s. We actually never had 80s, and we never had until 2004, 2003, something in there. And then 160s. 160s were the odd man out. So we actually went from 20s, 40s, 80s, 100. I think we went straight to 200. And then we ended up somewhere at one point in time with an actual 150, I think. And then the 160s are GMR heads. Those are after 2000. They have GMR heads, and they were 80 gig drives that are now doubled in size to 160. And then they did the exact same thing by adding another platter and got to 320s. So those were all odd mans out. And then two more platters get you to 640. But nonetheless, we had 100 gig drives back in 2000, 2001. So this is a 100 gig drive. Okay, now this drive here is 320 gigs. If I put this into any software, I'm going to be looking at 320 gigs. So I want to limit it to what my original source was. So I want the geometry to look the same. So that's what I'm going to do at this point. I can actually go into the destination, and on the destination menu, I have these three items. Set maximum LBA for HPAs, reset it to its original, or this is actually two commands. This is one command that says read it from the source drive and apply it to the destination drive. Otherwise I'd have to look it up. Like I have to go, oh, I need this number. So this is the number. And so I could manually go add that. I can make it whatever I want. I can set it and I can type it in. So this is the native value of the destination drive right now, 320 gigs. And I could type that number in and I would get the answer. Does that make sense? But if I just do this, if I just say destination and then do set maximum equal with source, when I hit enter on that, it already knows the number here and paste that to my destination drive. Everybody understand so far? So at that point in time, anything that's above 100 gigs is not accessible in Windows. Minus 1. It's 0 because we can start with 0 versus, because we have an LBA 0 for our MBR. So it's always going to be off by 1 when you're counting actual numbers. So that's where your difference comes from, is 0 or 1. Counting from 1 versus 0. Okay, so everybody okay? Everybody good so far? That means anything that I do in Windows. So now, just to make sure everybody understands what we're doing here. So if I take, I have not currently, now I will tell you, here's the other thing about setting HPAs, is setting it in the system area. Once the system area is read, you don't have to reread the system area, so that means you also can't reset it twice. So any changes that you make to the system area only get done once when you first make the change. Otherwise, you have to power off the drive and power it back on every time, which is easy to do here. I can hit F12 and turn it off and turn it back on. But on the destination, I can't do that.
I just had a question. I know you're saying F11 power on, F12 power off. But is that, you have two drives plugged in there right now?
Yep.
So when you hit F11, it powers both of those? Is that what's happening?
So look in front of you on that motherboard, and you'll see that there's a destination drive. And if you follow the cable that it's plugged into, you'll see it goes up to the power supply on the machine in front of you. So it is hard powered from the power supply to that hard drive. The only one that's powered on F11 and F12 is off the top of the card, that cable that comes out. See the cable?
The one on the top?
Yes. So the other one, and you can do this on the Deepspar right there in front of you. But so this right here is the source
F11.
drive. Right, this would be the F11. So go ahead and hit F11. And so now it's turning the drive on, and then we're waiting to see drive seat complete, drive ready. And it may have already done it. It's a refresh thing. Hit R. Let's see if it actually... So now you've got model number, serial number, and your geometry. And so it's going back and forth.
So this one, that you said that's the source, right?
Yes.
So this is a destination.
Correct.
So the destination one, you just have to do manually.
Correct. You actually have to turn the machine off because you're actually connected to the power supply of the machine. So this stays on all the time till basically you're done.
Gotcha.
And then when you're ready to disconnect it, you're actually turning the whole machine off, taking off the destination drive.
Okay. Gotcha.
Okay. So everybody good with that? Everybody understand what I'm saying? So
One stupid question is you always use that command of set HPA similar to the original. You always do that.
yes. So I have a process at the end that I do the same handful of things all the time. And so I have every time before the end of the job. And there's a reason I do it at the end, because if you do all the stuff at the beginning, you don't remember when you're about to take it off. So I'm managing this data recovery all the time. So it may go on for a week. But at the end, when I finally go, you know what? I finally got a really good read. I finally got that number as close to 0 as possible. And there's a statistics screen. When I finally get that far, I'm going to say, I'm going to take this off of the drive, and I'm going to go plug this into Windows, and now I'm going to extract the data, and I'm going to give you the data. Does that make sense? So I do the same three things almost always. So if I'm looking at the destination menu, and I haven't covered everything yet, but if I'm looking at this destination menu, I do it right before I'm going to unplug the destination drive to take it over to a Windows machine. So what I'll do first is I'll set LBA equal to the source. So now I'm cutting the drive down to that size, so that when I plug it into one of these tools, it doesn't look at any extra sectors that I don't need to look at. There's a caveat that could actually be a problem, and it was a problem in early versions of the Deepspar, but they dummy-proofed it. So what happened is, the Deepspar didn't used to do anything you didn't tell it to do. So it would not wipe sectors on its own. Now it wipes sectors that are outside the LBA blocks on its own. So when you say wipe, so there's a wipe unprocessed sectors. When you say wipe unprocessed sectors, it will also wipe the additional space on the drive that doesn't belong to the drive. Does that make sense? Like, in other words, here's 100 gigs and I'm on a 320. It will actually wipe the remainder of the 320 and not the 100 gig, not just the 100 gigs. It used to only do from 0 to the 100 gigs. That way, if I set the HPA, it would limit it to the 100 gigs, and I didn't have to worry about what was in the extra space, and it was quicker. Now they wipe them all because somebody had a problem, because people didn't understand what to do. So in other words, you did one recovery and you did not sanitize your hard drive. So let's say I did a recovery on a 300 gig drive, and I had porn or naked pictures of a guy's wife in the last part of the drive. And then I did another recovery for a different guy, and it was 100 gigs. If you don't set your HPA, you give the pictures of the guy's naked wife to the wrong guy.
That happened to me. I couldn't believe it. This guy told me, but this is not my information. I said, no, it is.
So that's how that happens when you do not hit these buttons.
And sometimes it's good to sanitize the drive anyway, because even if you use the HPA, for example, if we give it to another police agency, sometimes they might connect it with Tableau devices, and they remove the HPA automatically, right? So if you don't sanitize that drive, you might have other information there that might get everything thrown out of court.
Yep, yeah, because it's not user data, but you technically should never give the other agency the that drive, right? Like, that's why I say it never leaves my place. I never leave. Yeah.
When you're, I'm sorry, maybe I missed something. When you're doing that, that's not changing the HPA though, is it?
Which one?
When you wipe.
Right. No, it does not. This. So here's the other thing. A Deepspar ignores all of those settings. So when you plug in a hard drive and there's an HPA, it'll warn you and it'll tell you it's set. But a Deepspar allows you, a lot like what he just said on the Tableau device or something, where they'll clear the HPA. The Deepspar doesn't need to clear it. It just doesn't use it. It completely ignores it.
Okay, I guess we'll probably get into it later when you
Yeah,
start going.
so-
But I was just looking at the process. So if you're constantly using that drive,
Yes.
uh,
Right. All right. Let's start over. Let's start from. All right. So a hard drive comes into my office, and I have a process that goes with the hard drive, which is Xerox the label, document it all. It doesn't go into a tech room until Allison, my front office manager, documents everything that came in. She Xeroxes it. She separates the hardware from the hard drive, and only the hard drive and a copy of the paperwork goes into the tech room. Okay? So then there's just a hard drive and a copy of the paperwork. And anything else that came with the equipment is documented and put in a box up front, so that when the shipment goes back out, Allison goes and gets all that stuff, boxes it all back up together, it's all labeled, and then goes back out to the client. Okay? So in that process, comes into my lab, comes into the tech area. Now I've got a hard drive. On the shelf, I have a stack of 100 hard drives that are all different sizes. 2 terabyte, 4 terabyte, 10 terabyte. I look at this drive. This drive's 100 gigs. So I can use anything bigger than 100 gigs. I just want to use something bigger than 100 gigs. Not equal, there's a reason not equal, but bigger than 100 gigs. So I go over there and I pick up a 320 gig drive. That 320 gig drive was used for another recovery. I'm not wasting a lot of time on recoveries. Now, the recoveries are different than forensics. Forensics, you sanitize, you make sure everything's clean, you do the whole process all the time. Data recovery, I have 8 drives a day coming in. I don't have time to wait for 3 hours for every drive I ever touch to be erased, right? So the Deepspar's idea is only erase what you're not copying over. That's its idea. So that way, if you're copying and you're cloning 100 gigs, you only have to erase. If you actually are successful at the 100 gigs, you're only erasing the other, 220 gigs or whatever else is left. So you're saving time by not having to do that. So I go over there, get a 320, I bring it over. There may have been stuff on it from the last recovery that was on there. But now, when I plug that into the Deepspar, and then I plug the source drive in, the Deepspar recognizes that the configuration information for this drive from the last recovery does not match the serial number for this one. So the Deepspar stores that. So when I'm on, here's my source drive, and I look at this passport. This is the source drive, and it actually contains this information right here, serial number, model number, and LBAs. On the destination drive, when I imaged it, on the destination drive, you'll see that there is the disk passport for the destination drive, and then you'll see one called, it should have been called source drive passport. They store the data from those 2 married drives on configuration information right outside the end of the last sector. So this drive is 100 gigs. So if I'm using a bigger drive, I need like 4% of the drive, bigger. So right outside of this, a couple of sectors past the end of this drive, there is some binary information that the Deepspar writes to that drive on the 320 gig. Does that make sense? And that information includes the source drive's information, so you know what 2 drives are married together. So the information from the source drive is written in a configuration that exists on the destination drive. So it knows they're married together. So right now, every time, I just powered on the machine, right? Well, see those green boxes right there? I already imaged this hard drive. I previously had imaged this hard drive, and it kept track of the status. That's not how it looks when it normally comes up. When it comes up normally, it will be blank. It'll be this. It'll be, I'm going to clear the configuration. This erases, this button erases that information that married the 2 drives. That whole configuration of information that married those 2 drives together, I'm erasing it. I hit this button, yes, it's gone. Now this is what it looks like when 2 brand new drives come up and see each other. When 2 brand new drives come up and see each other, it's just a gray screen, nothing there, and there's a little bit of logging information there. That's it. It'll usually say serial number, model number. Like when I first power up the drive, I set them up, I do this, and I hit enter, then what will happen is it'll immediately say, oh, no configuration data is found. I'm using the defaults for the application. And then sometimes it actually shows the serial number and model number. But at this point in time, it has written nothing to the destination. At this point, 0 has been written to the destination drive. So if you make a mistake and you hook up 2 drives that you didn't expect to, you're still safe. You're still good. You didn't accidentally erase your data. Does that make sense? All right, so now the next step would normally be I'm going to start imaging. Now you can do a number of different things, but to begin with, right away, if I had already seen this screen and I got model number, serial number, and then drive seek complete, drive ready, this is a good, like 99% of the time, if I see this, I can hit go and it'll start imaging and I'll get some green sectors. 99% of the time, I'm in pretty good shape. Does that make sense? So normally what happens is you're sitting here working on your head assembly, you hit enter, you finally got it that far. Now the next thing you're going to do is the next key you're going to hit is F5, and that's the start button. And it's the only one you can click initially when nothing else has been done. When nothing else has been done, F5 is the only thing. It's also the same thing as Control S. So old school people use Control S because we've been using it for years, but F5 is one key. Okay? Once I hit enter, it will start trying to clone this drive. So the very first thing that it will do, you see this Initialize Map? That's writing that configuration data underneath that end of that last sector. It's writing a bitmap that tracks all of these sectors as they're green. So I can stop this at any point in time. I'm going to stop it. So I just hit the letter Z to stop it, because any key that's not programmed, you can just hit. So I stopped the image from happening. It's just waiting for me now. It'll pick up where it left off. If I tell it to go again, it'll just continue where it left off. Everywhere a sector is green has already been copied to the destination. It never touches it again. If it's green, it will never touch it again. It has already touched it and only touches it once. The whole point is safety of the drives. So if I went back to the beginning of the drive, if I hit the home key, just like you can use all the same keys you use in Word and Excel, things like that, your home key takes you to the beginning of the drive. So now I'm at the beginning of the drive, and these sectors have all been copied. If I hit go again, it will not recopy those sectors. They now are that, period. Understand? So I'm safe. If I hit F5 and hit enter, it will continue where it was. It will skip all of the green, and it will pick up where the white ones were and start copying the white ones again. If some horrible thing happens and it powers off, I'm not going to power off because of time, but it powered off for some reason, it was completely dead, and I had to reboot. As soon as I come back in, I'll have to still power. Now, if I lost power, the power wouldn't be on. So, at least at this point, I still have my drive live. I'd have to hit F11, turn it on, hit cycle again, hit enter. As soon as OK comes up, hit enter. You'll see I am exactly where I was. So, it will have the same state. All of those things will have been tracked. It has a little map and tracks everything. Everybody good so far? That's the whole point. I can do it at any point. I can do it anywhere. I don't even have to image from the beginning of the drive. I can image from the end of the drive. So I'm going to start, somewhere else on the drive. I'm going to go to 190, 190, 123, 123. I'm in like the last 5% of the drive, right? Bam. So now you'll see it's now at the end of the drive copying. I'm at 97% of the drive. Now, I can move around, and you'll see right here, this is a map. There's numbers 1, 2, and 3. You have 3 different views that you can see. The initial one by default, which I hate, but the initial one by default is this full map. I really don't want to see the full map. What I want to see is stuff in hex, because I'm used to seeing that, and they changed that, and I don't like that. I hate it. Because it used to show it in hex by default, and now they changed that. So I can switch screens if I want, but by default it's showing you. This is a picture of the whole drive. So the way that this works is menu, status, errors, and then how many sectors you've copied, not copied. So I've had 120 errors. This little line right here means I'm alive. So when you're doing something that you know, if it's paused and it's grinding on a sector, this little line will go up and down to let you know I'm not stuck, I'm not dead. There's little status items here which I don't think are documented, but I can tell you what they all are. So right now I'm doing a block copy, and my block size is 120. So I'm copying 120 blocks at a time, and I'm doing that in 5 to 7 milliseconds. So I'm copying a full 120 sectors in 5 to 7 milliseconds. Now I know it's 120. There's nothing on the screen that tells me it's 120, except that I can guesstimate. I don't have 240 bad sectors. I have 2. But it skipped them. So the way that the thing is set up by default is it skips if there's an error, and it skips the block size. So if my block size was 40 and I skipped 2, it would be 80. And I can show you where the block size is in a minute, but I just know off the top of my head that's where it is. Okay? So menu, status, things to tell you if it's alive, how many sectors you haven't copied. Now these are not the ones that are white. These are only the ones that it tried to copy, had an error, skipped them. Okay? Understand? I'm going to come back and get those later. But that initially, this is why it would have died on Encase, or this is why it would have died on FTK. Like if you tried to image it and it hit that error, it would just stop and wouldn't make it any further. This tool lets you keep on going and come back. So I do all this. This is a picture of the whole hard drive. So I'm at the end of the drive. I've done some at the beginning of the drive. I've got all this white stuff in the middle I haven't done. And then this is logging, and all of this logging is written into that binary file that's right after the end of the sectors. And you can read that with the Windows tool. So there's a Windows tool that you can go and mount the hard drive, and you can read this content. There's more of it that scrolled off the screen. Okay? This part right here is for information purposes only. It doesn't do anything except give you information. And the information is this. If it can tell you what file it's on, which there's a whole nother process, and we'll get into that later. But right now, it doesn't know what file it's on. I have one MBR, master boot record. So it knows by the header that I have a master boot record. It knows by the header I have document files. So these are Word, Office documents, things like that. There is also, you'll see also in certain versions it'll say MSO or something, Microsoft Office documents. Pictures, 17 pictures, whether they're JPEGs, BNPs, bitmaps, whatever they are. Media files, movies, things like that, WAV files. And then now I'm in NTFS, like now I've got 26 MFT records. So those are file records, and these are folder records. So I have one boot block, MFTs, and indexes. So I know sanity. This is basically sanity. So I'll try to explain more as we're going into NTFS tomorrow, how we'll break all that stuff down so that I can actually tell a little bit easier what I'm looking at. But that's just counting records, and I know that that's 26 files. So, and that should, you know, depending on these numbers, they might not be 100% accurate, and there may be other files, but it knows there's records there. Now, the bottom line is for information purposes on transfers and things like that. So, here is where my cursor is. So this says LBA, and the block I am on is wherever my cursor is. That's the number. At the beginning of the drive, it's 0. At the end of the drive, it's the last digit, which would be this one, right? -1. So if I go to the end of the drive, so at the end of the drive, I am at the last one. This is the last one because we count from 1 to n. So, and at the beginning of the drive, it's 0. Right? Now, if you noticed anything, when I did 0 and out of that number, it changes the percentage. It is not the percentage you have copied. It's percentage in position of hard drive. So at 0, I'm at 0%. At end, I'm at 100%. It is not how much you've copied. Okay? That information is not on this screen. There is a screen for it, but it is not here. There is a statistics screen that tells you how much you've copied or you haven't copied. Okay? The next one is your transfer rate, how quickly it's copying the data in speed. Now, it goes up and down depending on damage. When you first start copying a drive, it may be super fast. It may be super fast, so it transfers really fast, and you'll see, you know, it'll go up and down depending on where it's at. And it will recalculate depending upon that number. So if you have damage on your drive, it's going to slow down. And when it does, this is Microsoft time right here. Microsoft time means you don't really know what the answer is. It goes up and down at will, and they change this number however they feel like it. So eventually, someday, maybe it'll finish, but you don't know when. It may not be. My guess is it actually only take 45 minutes or so. You really only know this answer the very first time that you run the drive forward. The answer forward is a pretty good estimate unless there's damage. Then it slows down. Does that make sense? So this really isn't a great estimate. Alright, so this list right here is important. The passes, you only can do 4 passes. And you can do them any way you want. You can do forward, you can do backwards. We didn't used to be able to do that. We always had to used to do forward and then backwards. You can do anything you want now. You can start backwards, you can go forward. the system will automatically adjust itself according to all the things that it didn't do manually before. But it used to be wherever your head was where it was. So you can only do 4 passes, and you manually get to decide what those 4 passes are. There are 2 by default, and sometimes there's 3. So there's a forward pass, a backwards pass, and then an ignore ECC pass, if there is a third one. But you can set up those 4 to be anything you want. They're just text descriptions of what that is, and you get to decide what all that content is. But there's already at least 2 decided for me, okay? So I'm on pass 1, which is normally a forward pass. So I'm going forward while I'm imaging. You can tell it how many times you want it to read a sector. So if you were doing ignore ECC, remember I told you I could say I want to do it 99 times? If I told it 99 times, then that number would say 99. Does that make sense? So it would crank up. It would go from 0 to 99 because it would be staying on the same pass, doing the same work over and over again. Everybody good so far? Now I'm on pass 2, and it's going backwards, reading anything it did not read in the first pass. So it automatically will go through these passes that you have given it. So you can basically go to dinner and not worry about your machine and imaging stuff. Even if bad things happen, it'll power the drive off, power it back on, and start where it left off automatically, almost always. There's a few rare exceptions, but most of the time it'll all survive. Does that make sense? And then the last things are your transfer time, and then you see this one, P4. What do you think P4 might mean?
Total of passes?
No, there's actually no total number of passes except for you could do 4, but you kind of have to know that. It just does pass 1, pass 2, pass 3. It doesn't actually tell you in this screen. There's another screen that tells you when you set it up. But so these items are related to transfer rates. Remember I told you there's 4 ways you can transfer data. DMA, PIO, LBA 28-bit, and 48-bit. So if you're in 28-bit, it'd be a 2. If you're in 48-bit, it's 4. If you're in PIO mode, it's P. If you're in DMA mode, it's D. Now you can be any of those 6, it doesn't make any difference. But so I'm going to go forward as an example. So if I hit F5 and I go forward, I'm going to go to the beginning again. Ignore the man behind the mirror. So I'm going forward again. In forward mode, I have it programmed to do DMA. So it is doing DMA in 48-bit. When it was going backwards, it was in PIO mode. So you can actually change those things on the fly inside of each of those passes. Does that make sense? So to show you where the passes are, those 4, it is actually right here in what's called process, the image process. So these are the 4 possible items that you can deal with. Okay? So you can make 4 passes. And so these are the 2 that are defined. And so the fast primary pass is a default and the secondary is a default. So this one's going forward in DMA mode as fast as it can, and it's set to 300 milliseconds. If the sector takes longer than 300 milliseconds to talk to it, it skips it, thinking maybe it's bad, I don't want to grind on it right now because maybe it's in a Windows System folder. If I skip that, I can come back later and get that later. And get the rest of the stuff so that maybe I get to my documents folder, which no other imagers, like all your other imagers, they don't do it. If it's not contiguous and you grind on that sector till it dies. I mean, how many times have you opened up an image after something died and it was only the Windows folder and you really wanted it to be the My Documents folder? If it had just skipped that, you could keep on going. So that's where we're looking here. So I can make each pass whatever I want it to be. And the way that I do that is this. On the first item called Available Configurations. Now, just so you know, we did settings, which was hardware, right? So I already told it DMA, I already told it which one I wanted to be, LBA 28-bit or 48-bit mode. I can check the box and change it, but that is not a programmed item in my list of the other stuff. I have to choose how I communicate with the drive by which ATA command set. Because that's ATA 2 and that's ATA 6. Right? Everybody okay so far? If I now tell it, now I'm on a Toshiba, and these things don't work great with other command sets. So I'm going to switch to LBA2, so I'm in 28-bit mode, and now I'm going to start copying from the beginning of the drive, whatever it didn't copy. So now I'm in LBA2. See it? I'm in DMA mode, LBA2. If I was going to use a long read, I could try it here, but Toshibas don't support long reads because they weren't around. They basically weren't doing it at the time. Everybody understand what I'm saying? So what I would do to try that though, like if I knew I was not getting some sectors and I wanted to try it, what I could do is this. I can go to my available configurations. There's one of these configurations that's called Ignore ECC. So this one's already set up for me. I know it's hard to read this purple color. They don't let you change it. It's called Ignore ECC. So this is one I would have to add to my passes. So you saw in my passes I had fast primary first and secondary. If I want to run this one, I have to add it to that list. Because I'll show you what happens if I try to run it and then don't add it to the list. It's not in my list right now. You guys know I didn't add it to the list, right? I'm going to hit F5 and I'm going to start the drive from where I'm at, and I'm going to tell it one of those items that's not in the list. See that? Ignore ECC. That's what I'm going to try to run. This is the stupidest thing that Deepspar has. And it used to be worse. I asked them to change it, and they changed it, and it's still worse. Like, I don't know what that... Like, watch this. Enter. Runs. Right? Goes to run. You get red in this item. It says, error. Index of the current pass is over the limit. No one knows what that means. No one knows that. It used to have another box that says something like pass is impossible or something like that. Like, at least you knew it was something to do with the pass. You had no idea. Not only did it do that, it ignored what I told it to do and started all over at the first pass. So I didn't even know it didn't do it if you didn't pay attention to that log. So it did not execute that one because it was not in the list. That's all that means, is it's not in your list. Understand what I mean?
So is it what it's doing is it's because it's not in the list, it figures you already had 4 on the list and now you're trying to do another one, so it's...
No, it just limits you only to the items in the list. It doesn't do anything else, and so it always blocks you. And it used to just stop you and give a box in the middle. Now it just ignores you altogether and just does something.
And is the 4 pass, that's just the parameters that system set up by?
Yeah, it's probably also due to memory. Like the Atoll doesn't have a limit. Like you can just keep adding them. Like it has like a whole, I can do however many passes I want, and you can just keep adding them. You can even keep adding different configurations, and it's got a lot more memory and a lot more things it can work with. The Deepspar, I think it's just like they just hard coded it into the 4 passes. I don't ever feel like I don't have enough.
Oh, really?
Yeah, I don't ever.
Would you ever get in a situation where 4 passes wouldn't be enough, and then you...
I don't think so, because the other thing is too, anytime I stop it and then I restart it, I can restart it at the first pass again. So if I just add more, change more, do something more, every time I run it, there'll be 4. And it's really just to keep me from having to be here all weekend. Like literally, I can change something, go home, come back on Monday morning, and then it's done. So if it didn't work out exactly the way I expected, make a couple of changes, go to lunch. I don't really ever feel like I don't have enough. I rarely use more than 3. But as an example, I'm going to go to process. I'm going to go add. Ignore ECC. Now it's in my pass list. Now I'm going to hit enter. It saves it. Now if I go and I say I want to run that one by itself. Now I can always start from the beginning and just say start the first pass. But usually that requires you to reset. But anytime I take it to the first pass, like for instance right now in the first position, it says fast primary pass. It will now start at pass 1 and it'll run through all 3 passes. If I tell it to go to the 3rd pass, it will start at the 3rd pass and then it will be done. Does that make sense? So you have to execute it from here. So this is tab and then you hit spacebar on the box that you want to check. So it's tab and then spacebar. And then I can change this number to whatever I want it to be. I can be 50% of the drive. If you hit the letter M, it will automatically make it the last one. So if I hit M to go backwards, so if I did this and I said M, it'll be max LBA, and then I would probably be running a backwards pass at that point, because if I run forward on a drive, here's the thing, cache on your hard drive, let's say you have a 2 meg cache on your hard drive. When you buy a hard drive, it says I have 2 meg cache or I have 64 meg cache. Cache is in advance. So where your head is starting on the outside edge of the platter, when you are reading sectors, you think it's at LBA 0, but it's 2 megs ahead of you. It's already read whatever your cache says. It's already up there reading data. When you go backwards, it's an individual transfer. So it's a poor man's turn off my cache. There is a command that allows you to turn cache off. And if you don't have a tool like a Deepspar and you want to use Linux, just image backwards. And it'll only do the transfer of the current sectors in the block across the bus. And then it won't fill up memory. It's only going backwards on those sectors. So you read differently. It reads completely differently, it's almost like an airplane's angle of attack. If you come from a different direction, different wind speed, different everything affects it coming in the other direction. So there's a lot of times going backwards works all by itself where frontwards doesn't work. Okay? So I'll try them both. But that's ultimately the whole point. So literally I would be at the beginning and I'm going to do ignore ECC. Now this is how I'm testing to see if it was going to work. It's going to do a long read and it's going to try to read that sector. And if it works on this drive, if this drive supports it, then I will then go make changes so that I can use this pass the way I want to use it. I just tell you it's not going to work. So this is what it looks like when it doesn't work. The drive doesn't support this command, doesn't know what to do with it. Now we'll have drives that will support the command. You'll be able to do this in the class. It's just Toshiba drives are terrible at this, and so it doesn't support this command. So it's just creating errors all over the place. Now I can fix those errors. That's not a problem. I don't have to restart over or do anything. I can now tell it focus on everything that says A. So anything that's an abort error, I can then focus on. So I can say each of those specific errors. Okay? Everybody understand so far? Yes? Okay.
A simple question.
Yeah.
You notice sometimes when you use Deepspar to do imaging, everything goes 100%. So in the middle, then all of a sudden you hear noises in the drive. Mm-hmm. You know what I'm talking about? You know, I just skip spacebar to try and get away from the noises. Is that right?
Yeah, I mean, that's not a bad idea. The whole point is that you may have damage in the middle of a disk. So, especially if you've done a rebuild, you've probably done a rebuild on those drives, no? So, what happens when you do a rebuild, so when your platter isn't exactly perfect, sometimes what will happen is you'll get a really good read on the outside, but the closer you get to the center, the more the angle is different. And so now all of a sudden you'll start hearing noises, like it's starting to eat it or do something else. So, so Spacebar is the skip button. So if you are in an area where things look wrong and like it's starting to make brown sectors and it's starting to not do a good copy, you can hit Spacebar and move ahead, skip ahead 1,000,000 sectors. It's programmable, but the default was originally 1,000,000 and they may have lowered it to 100,000. I don't remember. They change it sometimes. Huh? 100,000. So they change it sometimes in their defaults and their configurations as they release new versions. I don't go back and reload their default configurations, but Spacebar is and it's a documented command. But if you wanted to skip, I'll start it so you can see it'll be errors. But so things aren't looking right. Skip, 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 skip. You can see I'm skipping, and every time I skip, it's going forward. And now it's in a different place, and you can actually see it in the map as I'm doing it, and that I'm not getting the copy. So I'm skipping bad stuff, and then I can come back and do it later. Does that make sense? So I'm okay with that.
It's password protected, the same as that. Am I right? Am I wrong?
Is this what?
It's password protected. It's exactly like that.
Yes. If it is password protected, that is exactly what it will look like for every single sector. If it's password protected. But like I said, you can tell if it's password protected easily just by jumping into the source menu and then go into passport and then go to the bottom and see what your commands are that are enabled. If that's enabled, you know it's a password. If you get aborts like this and it's not enabled, then you know that's not it.
You're saying you're not using the defaults of Deepspar?
I used so my defaults were different than your defaults. As they release new versions and they do new updates, then they update their defaults. And so I still have my default files that I've been using for a decade. So I don't always know what the new defaults are they set for a new Deepspar when you first get one.
Are you on DI3 or 4?
I'm a 4, but I mean, these are 4s. All these cards are 4s. But because 3 doesn't support, there's a whole pile of things 3 doesn't support. So I typically use 4 for everything. But I have like 10 3s. I just don't use them normally.
One more question from a business perspective. Do you sometimes review things and advise us to maybe buy a DDI3? Can I think just take a hard drive that's an issue, DDI4, fix the problems, and of course it's like specific functions you can use, and then program a DDI3?
No, I don't think so anymore. Maybe in the beginning when there was some overlap, but not anymore. The configuration files aren't the same. Also, when you do it on a 3 and you move it back, it won't see the configuration file that you have. You have to be on the same versions. Sometimes you have to leave your Deepspar. If you're working on a case that's a really long time and you wanted to stop your case and move to another one, your Deepspar's configuration files are specific to versions, and at some point in time when they update them, the old ones won't work, and so sometimes you have to have a specific one to go back to. And so every once in a while I have to leave a Deepspar in the past and not do any updates to it so that I can still run my old configurations. So if you've got an old case or old thing that was working on it, it won't work on new ones.
How do you update the Deepspar?
Firmware port.
That's the thing they said I shouldn't do?
Yes, it's the thing they told you shouldn't do. You've got to have a 32-bit operating system, and it is painful. It can break it. So I try not to do them very often. I do them when a big update comes out. I don't do them for every little update.
What do you mean you get 32-bit?
The drivers only work on 32-bit for you to do your firmware update. They don't have 64-bit drivers. As far as I know, they haven't changed that. They still don't have 64-bit drivers. It's got to be 32-bit OS.
Okay, but you don't even need an OS to run Deepspar.
Yes, you do. To do a firmware update, you do. It's a Windows application.
Is it?
Yeah, I'm not talking about take your thumb drive out and change the executable. The minor things they can do that for, but big firmware updates are written to the board through the USB port. So any of that big stuff that says we've got a big firmware update you need to update, it's not just an executable. Because that rewrites just the memory stick that you're booting on. In case nobody realized that you're booting on a memory stick, and the memory stick is where the executable is. So that is a bootable memory stick, and then it talks to the Deepspar. So I don't have a C drive or a hard drive in the system. It's a memory stick. Okay? It comes with the Deepspar. Already done. You just plug it in your machine.
What are they going to do when you can't hardly find a 32-bit machine anymore?
That's a good question. At some point, somebody's going to have to write a driver. I mean, it is painful. I'm not kidding. It's not, I mean, you heard us talking about it yesterday. We have to have old machines sitting in a corner somewhere or have something that has 32-bit on it in order to do the update. I don't know what they're going to do. I mean, it's, you know, OSs are becoming painful. It's not the day it used to be. I mean, a bunch of us still have old machines, but it's not different for PC3000. Some things for PC3000 are that way too. Atoll is the only one that's not, because he actually got rid of all the previous support. He actually said, well, we're cutting it off here, and you have to have Windows 7 forward. Will never work with anything else again, and he killed all the support for everything else below it. Prior to version 4 or whatever, it worked on everything. It worked on Windows XP, but it doesn't anymore. None of that stuff works anymore. We had to upgrade all our machines that we had it on to make that work. Okay, so let's go down this list again real quick and make sure everybody understands where we're at. So again, settings, all the hardware stuff and everything you're going to do. I'm going to take this back out of LBA 28-bit mode because this drive doesn't support it, right? Even though I could copy the data, I can't use long read. So there's no reason for me to use this old command because it's not going to make it faster for me. It'll be faster in 48-bit mode. Understand? So I'm turning that off now that I know this drive doesn't support it. Okay? And then you can see down here, these are, so mine's 1,000,000. This is your jump, spacebar jump. So when I hit spacebar and jump. So on this page, the only other things you have to worry about, these are things you can do that make things automatic. I tend to not use automatic settings. I am not always happy with automatic settings because they'll get in the way sometimes, or they'll do things when you're not expecting them. So I do everything at the end before I unplug a drive. So I just manually do that. But it's sure up to you. If you want to choose to click some of these buttons, you're welcome to do that. And I'll explain these in a minute. Some drives have a problem. And then when you're dealing with speed, let's say I have a 4 terabyte hard drive. And if I put it in PIO mode, it works. But when I put it in DMA mode, it doesn't work. Well, in DMA mode, it will always fall to the highest one available for that drive. So this drive, even though there's UDMA 6, this drive supports UDMA 5. Everybody understand what I'm saying? If I need to find the sweet spot in the hopes that it works. So let's say I change to UDMA, and it's faster, but it doesn't work. I try to copy stuff, and it fails. But PIO mode works. That's telling me right away there's something to do with memory, there's some problem. I can try copying backwards, maybe I can get around the problem. Otherwise, if I need to find the sweet spot, I will manually select a lower number. So I will select UDMA 1 and see if it works. That way I have some speed, and a 4 terabyte hard drive isn't going to take months to copy. So you're looking for the sweet spot. They let you set that yourself. So you can play with the drive, just like I just did a minute ago, to try to find that sweet spot and get the best copy with the highest speed. It's really about time. It's really about if you have one Deepspar and you have a 4 terabyte and it's going to take 3 months, you try to find that sweet spot. Understand? You have to play with that. So at the moment, you don't have to worry. Most of the time, I don't have to worry about it. It's in the rare instances that something bad happens. Spacebar to jump, just like he was saying, when you see a bad spot and you want to test something, you can hit spacebar. And I do that for RAID arrays also. So let me turn off this ignore ECC. So one of the things I do, a stack of drives comes in a RAID array. And I want to see which one's the bad one. I don't know. It's a mystery box. They gave me 4 hard drives, and I don't know what's bad and what's good. You guys got the mystery box before, right? I get a mystery box all the time. They didn't number them. They didn't label them. 4 drives. They tell me it's a RAID 5. Maybe they're right. Sometimes they're not right. So I got 4 drives, and they don't even tell me which drives are bad. I take the first drive off the stack. I plug it into the Deepspar. I go ahead and hit start, and I hit F5, and I continue. And then I will do this. I will say, I'm going to hit spacebar, and I'm going down the drive. Now, I change my view to number 2. So in number 2, you can see items in hex as you're imaging them. So let me start this over. I'm going to make this clearer. I'm going to start as if I'd never seen a drive. Stack comes in. I'm going to see if they're empty and which ones work instantly. I'm going to do it as fast as possible. My whole point is to save time. So I'm going to hit F5. It's going to start from the beginning. I've plugged in the drive. I hit start. As soon as I hit start, I'm going to switch, make sure it's on number 2 so you can see it in hex. So this is number 2 in hex. Is there data?
Yes.
Yes. As I hit spacebar throughout the drive, my question is, as I'm going through this drive, am I seeing data? Because I'm moving a million sectors at a time, so I'm actually jumping down the drive. I'm at 65, 66, 67, and then, so a big chunk of that drive had data. I feel pretty good about that drive. So there's nothing wrong with this drive. This drive's working, right? So I'm good. So once I finally get to the end and I know that I actually have a good working drive, I don't need this copy anymore. I hit F12, I stop it. This drive is good and it has data on it. That means that the Dell tech support guy didn't tell the guy to erase the hard drive. I see that all the time. That a customer calls in, this is my RAID array, I got a drive that's dead in the RAID array, and I need warranty. And they go, no, you got to do this test first. And click this button. And they click this button and it erases the entire array. Have you heard this one? It happens all the time. I see them do it all the time. And so the only drives that have data on them will be the ones that were bad, because they couldn't erase them. The other drives will all be erased. If you get the array in that's completely... So if I have 4 drives, 3 of them must have data. If I do not have data on 3 drives, it's useless. So if I have 2 zeros, 2 drives are 0, I'm done. I don't even need to work on it. There's no point. Understand? Nothing you do will save that array. Well, if 2 drives are 0, you're done. That's it. So you get your evaluation fee, and that's all you're going to get. You're not going to get more. You're never going to get more data. Everybody understand?
You're talking about the RAID 5, am I right?
Yeah, if it's a RAID 5 and you had 4 drives and 2 of them are zeros, from beginning to end they're zeros.
I see, okay.
You're done.
Right.
Right. So the very first thing I'm doing is I want to determine 2 things. Are all the drives have data on them, or all the drives that are working? So I did 1. Then I did the second one. So the second one, I start over, I hit F12, I don't even turn the machine off or do anything. I hit F12, F11, turn on the second drive, then I go ahead and hit OK, continue. Now I'm going to go through the second drive, I'm going to hit Spacebar, I'm going to look, see do I have data. Everybody okay? Eventually, I'm going to run into a bad drive. The bad drive is going to be a drive I'm going to have to image. I'm going to have to fix it. I can't do anything with it. Let's just say it's dead right now, or something, or it's in a bad state. I will immediately unplug it and put it aside, and because I'll know that one has data on it, and I know I have to fix it. So then I go through the rest of them, and I make sure the rest of them are not blank. So now I've got 3 that are not blank, or 2 that are not blank, and 1 bad one, and 1 that's blank. How's that sound? Good for everybody? So now those 3 drives are working drives. I'll put those 3 aside. Now I work on the one that's the bad one till I get the bad one working. And we'll go all through that tomorrow. But this is how I check that really quick. And now I know I need to image this one bad one. So if I am not successful, imaging those other 3 isn't going to do me any good. I've got to get the bad one. If I don't get the bad one, I don't win. So I'll work on that now. So I'm making a judgment call. Everybody good so far? Yes? Happy? All right. All right, so let's start over again here on the Deepspar. I just want to make sure everybody understands this real quick because we've been going down through the entire list. I'm going to start backwards. I'm going to ignore these menus on the right. I'm going to start with the destination drive. So, you know this is information on the drive. You know this is information about the source drive. This past project ID is you can have a network card and you can have a Windows system that talks to all your Deepspar. So if I had 12 Deepspars on my network, I'd need to give them a name so I know what project I'm working on. So I could call this, you know, Carl's backup or whatever. I can put that in it's actually just a text box. So literally you put this and you say, you know, Carl's. That's it. And then it'll broadcast itself, whatever. You get the point. It'll broadcast itself on the network and I'll know which one it is. That's it. Doesn't do anything else. Everybody good? HPAs. At the end of the job, I always do this. I always set maximum LBA equal to the source. That way I chop off the end of the disk and I'm not going to process anything except what's on the source drive. Everybody good with that?
I'm sorry, you said at the end of the job?
At the end of the job. I always do it at the end before I unplug the drive. Because I might be going on for a week doing work on this drive. And I may have different things I have to do. Sometimes I have to take it off, put it on a Windows system.
But you're leaving this, you always leave this.
It's running. I'm working this drive. But at the very end, before I extract the data that I'm going to give to the client, I will always do a handful of things at the very end of the job. I do not do it at the beginning. So this is before I plug it in and give the client their data. So I'm going to extract the client's data. I'm finally done with the Deepspar. When you're done with the Deepspar and you're moving to your Windows system, I will always do set maximum equal to source. So that way I'm only working on 100 gigs instead of 320.
I'm sorry, I'm spacing it. I understand what that does. I mean,
right.
You don't want to work on more than what you have.
Why am I doing it at the end?
Yeah, I just don't.
Okay. So if you make all these settings at the beginning and it's 3 weeks later, do you remember if you made the settings at the beginning? I mean, that's the problem. It's a matter of when can you confirm that you did everything. And I always do it at the very end, so my process works at the end. If your process works at the beginning, that's fine too. But
maybe your end is, maybe I'm not comprehending your end. Your end is prior to you making the image or after you've made the image? After
I've made the image. So basically when I'm done with the Deepspar, when I'm at the end and I'm ready to unplug my destination drive and take it to a Windows machine and copy the data off to give it to the client, I'm done with the Deepspar. I'm not going to keep it on the Deepspar anymore. That's the end of my job on the Deepspar. I might do more work over on a Windows machine, but it's not on the Deepspar anymore. So